you did the first day, that'll be better than you all have an idea what's going on. Allison had to jump in on the second day. Did you go back and watch the first day? Does it make more sense now?
I watched the first
Good.
bit.
Yeah.
I know the path.
So
I'll take him to that.
I gave you guys a little example down here that I found online. What would be the one thing you'd want to add to this equation? We're down here at the bottom. We never really talked about this chart, okay? What would be the one thing you'd want to add to this equation? Heat. I would write plus heat because it is exothermic. Because it's exothermic. So then there's just some examples there for you. Nothing else to really do there, just if you want to look back on that. Flip it. So here we go. We have an equation here. Synthesis of hydrogen iodide. And we have delta H, which is plus 51 joules. So where am I going to write heat?
Left.
On the left. So heat is going to be on the left. And let's talk about a couple shifts. So if I increase the pressure, which way will it shift? None. Why?
Inert gas doesn't react.
I didn't say if it's an inert gas or not.
Well, then,
There's another reason. No.
Nice.
How many moles of gas do I have on this side?
2.
How many moles of gas do I have on this side?
2.
There you go. It's the same number of moles of gas on each side. Right?
oh, that's right. Yeah.
It shifts to the side with the least number of moles of gas. Well, if it's the same on both and you add pressure, it's not going to shift. Right? Okay. What if I increase temperature? Which way will it shift?
Right.
Right.
Yeah.
Why?
Because the heat's on the left.
It's endothermic. It's endothermic. So you have to add heat to shift it to the products. What if I increase concentration of H2?
Right.
Shift to the right. Why?
More reactants.
More reactants. So what does that do to Q if we're talking about Q?
Q is the constant quotient.
So Q is
Q is less than.
decreased.
Yeah, it decreases, so
Q is decreased, so you have to,
no, because they're
so it shifts right. It shifts right to bring Q back equal to K.
yeah, because Q is less than queens are less than king.
Right, because the queen is less than the king. And a deck of cards. Yeah, that's day 2. You missed a lot on day 2. This is going to mean nothing to you, actually. All right? You missed a lot on day 2. And then if I increase the concentration of HI, which way is going to shift? Yeah, to the left. To the left. Why? There's more products. So Q is increased. Q is increased, so it has to shift left to be back equal to K. Cool. Awesome. What about solids? I left a lot of room there. I don't know why. Because we're not putting anything else there. So just put a nice smiley face right there. There you go. Are you happy?
You couldn't have used some of that space for like other areas. There was no space.
I'm sorry. I'm sorry.
You should draw an oil.
Every year, I've only done like guided notes for 2 years. I'm like, I want to get more space next year, but then I don't. So, what about solids? All sodium, potassium, and ammonium nitrate salts. Do you guys remember this? We'll say completely, actually. All right, for this purpose. They're actually completely soluble in water. But some other salts are considered to be insoluble. In reality, even insoluble salts dissolve to some degree, because we know that most of chemistry is just a lie, right?
Oh,
Yeah.
Because then you find out, oh, that's actually true later, or not true. And equilibria are set up in solution. For example, it's possible to set up an equilibrium where a saturated solution, one where the most solute has possibly been dissolved, of silver chloride is in contact with an undissolved solid silver chloride. Do you guys see it here?
Yeah.
Yes? So, since pure solids are never part of the K expression, what would the KSP? Guess what SP stands for?
Simplified.
Solubility product. All right?
Duh.
Just another K. We've had like 4 Ks already this chapter. Same thing though, but it's going to be the concentration of what? Concentration of Ag plus
CL negative.
times the concentration of Cl minus, because there's no reactants to put it over. Agreed? Flip the page. So KSP, like I said, is defined as the product of the equilibrium concentrations of the constituent ions it breaks up into, raised to their stoichiometric powers. Well, coefficients, right? Yes? It'd be their coefficients. And it's called the solubility product. That's the solubility product. The smaller the value of the KSP, the smaller the number of ions that have gone into solution. Therefore, it's the less soluble a compound is. Therefore, the less soluble the compound is in water. Because we're talking about water as the dissolvent here. The concentration of ions that have gone into solution is usually expressed in terms of, this is called molar solubility. Molar solubility, i.e., the number of moles of solute in 1 liter of saturated solution. However, solubility may be expressed as the number of grams of solute in 1 liter of saturated solution. Obviously, these two terms are different definitions, and sometimes you have to convert. That's all I'm saying. So sometimes you'll see it in grams per liter, and you'll have to convert it to moles per liter. That's it. So, at a certain temperature, the molar solubility of the salt M plus 2 X minus 2 is found to be 4.15 times 10 to the negative 6 molar. Calculate the KSP of the salt. Step 1, write the K expression. So KSP is going to equal what? Concentration of M2 plus times the concentration of X2 minus. KSP equals what? 4.15 times 10 to the negative 6 what? Squared. Yes, molar. Yes, molar, but squared. Because we're just going to square it. It's the same thing. This is for both ions. Sorry. This goes to both ions. So whatever the molar solubility is, you substitute that in for both ions. So you're just squaring it. So put that in your calculator. What do you get for KSP? Just square it. 4.15 times 10 to the negative 6 squared. Should be a bigger number.
Like, how so bigger?
Smaller number, yeah, you're right. A bigger exponent to the negative is what I meant.
1.72 times 10 to the negative 11.
That's what I got. I had 1.72 times 10 to the negative 11. 1.72 times 10 to the negative 11.
No unit.
Oh, no,
No units on K. All right, even though there technically would be here, there's no unit. All right, you never put units on K. At a certain temperature, here we go. So calculating KSP from the solubility in grams per liter. At a certain temperature, the solubility of calcium sulfate is found to be 0.66 grams per liter. Calculate the KSP for calcium sulfate. Step 1, I cannot use gram per liter. What do I need to have that in? Molar. So my 0.66 grams of what? CaSO4 over 1 liter. What is the molar mass? I'll just tell you. It's 136.14 grams of CaSO4. We're not getting our yellow sheet out right now. We don't have time for that. In 1 mole of CaSO4. That will give me molar, yes. So, the point of this is me just showing, sometimes we'll give it to you in grams per liter. You have to convert it to molar first. Yeah, see. Did you try out for this spring drama? Did you get it? You in? Are you Harry Potter? Oh.
It's not Harry Potter. It's about the Harry Potter.
Oh, sorry.
So Harry Potter's friends.
What'd you guys get?
4.85.
0.00485 molar? Yes? Or 4.85 times 10 to the negative third? Yeah. Okay. And now, solve for KSP. So KSP is going to equal concentration of Ca2 plus times the concentration of SO4 2 minus. So that means that KSP equals 0.00485 times 0.00485, because they're both the same, because they're in the same solution. So KSP should be a smaller number.
Yep.
What'd you get?
2.35 times 10 to the negative 5.
Yeah, I had 2.36. Or at 2.35 though. 2.35 times 10 to the negative, what? Fifth. Yep. You got it. You can work backwards as well. Question, Aubrey.
Why are they the same?
Because these are in the same solution. The solubility of these are going to be the exact same because they're all in the same solution. In the same solution. Working backwards, calculating molar solubility from KSP. But now, not everything is 1. So, given the KSP for Ag2 SO4 is 1.41 times 10 to the fifth, calculate the molar solubility in moles per liter of Ag2 SO4. Step number 1.
Write your expression.
Rice.
Oh, it's rice. Okay.
Gotta erase this one.
Uh,
Write your equation. Ag2 SO4, which is a solid. Does this go both ways?
No.
yeah.
No, it really just, I mean, it's really mostly going to the right. If we're talking about solubility, do I have any water here yet?
No.
It really only has one way to go if you're dissolving it. Agreed? But we'll write it both ways, just because. Because as soon as you add water, it's going to go both ways, right?
Yeah.
Either one. Okay? So this is going to give me what for my products?
2 Ag
2
plus.
Ag plus SO4 2 minus. So this is what I think Jacob was asking about either last time or the time before. Initial concentration. What is my initial concentration of solid?
1.41 times 10.
Guys.
Oh, it's a molar.
Solid, solid, solid. Nothing.
I thought you said.
That's a solid,
Whoops.
right?
So
As soon as there's a solid,
That looks like a G to me.
that's an S. All right? As soon as there's a solid, it's not part of equilibrium. Solids are not part of equilibrium. Get rid of it. What's my initial concentration over here?
We don't know.
0. If I haven't dissolved anything, you're not going to start with anything, right? Yes? Plus how much?
X.
Plus 2x. Because now I have a coefficient on this other ion. This is going to be plus x. So I have 2x and I have x for my equilibrium. And they gave me k, agreed? So I'm going to write my k expression. So KSP equals concentration of Ag plus to the second times the concentration of SO4 2 minus. So this is not hard. There's just lots of steps that can mess you up. First one, did you have the 2x here? If you forgot the 2x here, you're probably going to forget to square it over here. There's lots of steps where you can make a mistake. So this means that I'm just going to sub it in. KXP equals 2x squared times x, right? So KSP equals 4x cubed. Agreed? Sub in your k. 1.41 times 10 to the negative fifth equals 4x cubed. And what did you get, Eric? You already got it?
No, I was
Oh.
just subbing in 1.4.
Oh, got it. I just waited to sub it until the end. I didn't want to have to write that number 4 different times. Cube root. Just raise it to the power of 1/3. What'd you get?
0.0152.
0.0152 what?
Molar.
Molar. 0.0152 molar. So there's your first rice table where you actually had something different than
So like,
X.
what would our answer be? Would be we have an answer for 2Ag plus and an answer for SO4 and 2 minus, or we just define rice?
This would cover the more solubility of the compound.
Okay.
So it's the same. It's the same for all of them, right? Because it's all in the same one.
Even though there's 2 AG.
Even though there's 2 Ag, yes. It would be this solubility. So you would say 2x equals this solubility. We're not solving for x
two
here.
times that many
Right.
moles of
Yes.
silver ions, but that's already true.
It's already true. Yes. It's the same for all. Flip it. A tip and a word. A tip and a word of warning. How about QSP and KSP values? Well, I mean, if there's a KSP, there gotta be a QSP, right? Because if there's a K, there's a Q, right?
Where there's a K, there's a Q.
Q would be the initial for the solution, right? You can write a Q. You can write a Q for those, yes, at just a different time, yeah. A direct comparison. Can someone grab the door? A direct comparison of KSP values to determine the relative solubility of a soluble salt should only of a sparingly soluble, so it's soluble in some way, should only be made when the two salts involved have what? The same ratio of cations to anions, or when they both are equal to X, right? For example, AgCl, that's a 1 plus and a 1 minus. BaSO4, that's a 2 plus and a 2 minus. Those would work because the ratios are 1 to 1. And their Q over K would both, their Q or K expressions would both be K equals X squared, right? So I'll give you an example. The larger the K will result in a larger square root of K, hence the larger X value, and hence the greater solubility. I'm very hensy here. However, this does not necessarily work so easily with salts that have different ratios of ions or different X expressions. So the KSP for FeOH2 is 8.0 times 10 negative 16th. And the KSP for AgBr is 5.0 times 10 negative 13th. You might be tempted to say that AgBr is more soluble, but we don't know that. You can only compare the solubilities if they're both a 1-to-1. Does that make sense what I'm saying? You cannot just compare this number and this number because this is a +1 minus 1. This is a +2 minus 1. So it's going to be a different ratio. So you can see when you solve it, this is actually, that number equals 4x cubed. This one equals x squared. So you can see FeOH2 is actually more soluble. That's a bigger number. Yes?
Yeah.
So that's my word of warning. Okay? AP may ask you to infer, and I hate it when they do that, solubility from KSP values rather than simply recall solubilities. So, for example, it may not be sufficient. All right? It unfortunately may not be sufficient to know that AgCl is insoluble, which we know that, right? Yes?
Yeah.
We know that silver chlorides, right? Silver, it's on the back of our periodic table, not soluble. You're going to have to review that. But rather, you may be expected to say something like, because the KSP value is 1.8 times 10 negative 10th and is very small, this suggests that very few ions enter solution and the salt is essentially insoluble. So, just be ready for that. You're ready. AP is basically cool. If KSP is greater than 1, then the salt is soluble. The salt is soluble. Okay. So, a little bit of review, a little bit of something new. You guys know what these are already. Delta H is what? enthalpy.
Oh yeah.
You guys knew that.
I was gonna say. I said.
And then delta S, we've talked about this maybe once, is entropy. More on that coming up in about a month. All right, entropy, disorder, right? That's disorder. E-N-T-R-O-P-Y. Entropy is disorder. What it used to be, yes. And then we'll also, eventually we'll have a delta G. Something else. But, here we go.
You're a delta G.
Yeah, that's right. You're a delta G.
Sounds like a sorority.
It does. We should start the delta G. Hey, are we going to do a Valentine's Day party?
I would be down for that.
Yeah.
Kale, I was right with you.
We could like decorate boxes and like have like somebody like judge like the best chemistry themed box.
Guys, I feel like there's good chemistry.
Yes. Are we gonna do it?
I think
What day is February 14th? Is it a day of the week?
Yeah, Tuesday.
A Tuesday?
You just know that.
I'll be here.
Oh, I don't know.
I'll be here. Are we gonna do it?
Yeah, that is a fly.
Are we gonna bring in Valentines for everybody?
Yes.
Oh, dude, I
Oh
would.
yeah, for sure. I'll
Like the
literally go
really
to the
bad
store, but we
ones.
also have a decorated box.
I kind of want to do
It's
it.
cute though. It's
Yes,
cute
dude.
though.
Now,
I
last
saw like 3 TikToks of married
Now,
people doing that, so I
so here's what we'll do.
okay.
For whoever wants to participate, which I think you all should. All right. Here's the rules of the Valentine's box. You have to make a chemistry themed Valentine's box. All right. I'll have a guest person come in and judge them.
Who's the guest?
Bring in a beaker.
What? You know, it has to be a box, right?
Oh, I have an
A
idea.
beaker in a
I'll
box.
write this down.
I'll have a guest person come and judge them. There will be prizes
Oh.
for them. Yes,
Is there like a size limit on the box?
like a shoebox.
What if I make it
Well,
like?
you got.
What if I have really good
How about
shoes?
like
Then
those large movies?
You've got to bring in a Valentine for everybody in the class,
Yeah.
obviously.
What do you
13? Well, one for me, so 14. So the thing is, you bring in 14, then you end up with like one for all of those. 14. Yeah. Anyways, does anybody need a shoebox? Because I have some extras I saved.
Yeah,
I wouldn't turn that down. Sure.
If you need a shoebox, let me know. I'll bring some in tomorrow.
Dibs.
All right.
I'm so excited.
Oh, speaking of, and then we'll like have like we'll plan some other like snacky food to go with that. I'm not saying we're taking a whole day off, but I'm saying it could be part of the day. We could probably do lunch and then like do our regularly scheduled.
Programming.
Speaking of regularly scheduled programming, the lab is postponed to Wednesday.
No.
Tomorrow we have to do Poggle because it's the dog and pony show, and I got to go talk and do all that stuff.
Wait, we don't get to go to that?
You guys are seniors.
Can we go to that?
Allison will have already seen it. I'm assuming Aubrey knows what she's taking next year.
But we missed.
Right?
I want to go to it.
You don't? If you
Yeah,
want to go, you
this is my
can.
first normal year. Don't worry.
It's up to you. The Dog and Pony Show is where science teachers
I don't know what science
just
is.
talk about what the classes you can take next year is. What?
I don't know what science is. Can I go?
No. Abby's graduating. Allison would have already seen it in another class because you have 2 sciences right now, right?
I never saw it.
Yeah, so you'll see it in another class. You can decide if you want to go.
What science are you?
It's essentially just teachers talking about classes you can take next year.
What are all the new restrictions?
I'm taking
and,
three
requirements,
Englishes.
like prerequisites?
I don't think there's a lot.
You can't take chem with the AP chem without chem. You can't take AP bio without chem.
I think they're just following the college board, right?
There's one taking.
Yeah?
Yeah, I'm glad.
So, we gotta reel it back in. I got us way off. All right, way off. If you guys want to go, you let me know.
This is an example of entropy.
You can just do the Poggle over the weekend if you want to.
Class is gone.
Like for the
Or you can just stay. I don't care. What you guys decide is fine with me. All right. The lab is postponed to Wednesday because I will not be here Monday and Tuesday.
Works out well for
I will be at, neither will Jacob. All right. I will be at a conference in Columbus Monday and Tuesday.
Oh.
So,
Do good conference things.
and then I am watching a system for next Wednesday. I don't know if you've looked that far ahead.
I doubt.
Oh.
Wait, you have
I
what?
could be. I'm watching a system, just a weather
Might
system.
be a snow.
Next Wednesday, Thursday, somewhere in there. So we'll see.
I don't think so.
No, I'm just.
You could keep this up like.
I don't think so at this point. I'm just keeping my eye on something.
What do we do Monday, Wednesday, or Tuesday?
AP review. So I have AP review actual FRQs. You're gonna be working
Just
through.
take a weekly dance.
And I have those, Jacob. I can give those to you now.
That'd be great.
Okay, not now. After the period.
I
Okay.
need that.
Enthalpy, entropy. I don't know how that led me to Valentine's, but disorder. Valentine's Day can be very disordering. The separation of the solute particles from one another. All right, or for breaking them up. All right. So if I'm breaking an ionic bond, that would be an endothermic process, right? Because you'd have to put energy in to break them.
Yeah.
The separation of the solvent particles from one another. So breaking the hydrogen bonds between water molecules would be an endothermic process. It takes energy to break those hydrogen bonds. But the interaction between the solute particles and the solvent, once those happen, that's actually an exothermic process because they want to, right? You saw in our water bottles over there that those ions want to interact with the polar ends of the water. So that is an exothermic process. Yes. In addition to enthalpy changes, we also need to consider entropy changes. When a solute dissolves, entropy increases, right? It's going to be more disordered. Yes? Okay. Flip it. The common ion effect. This is what tomorrow's Pogel's on. All right? If a solution contains two dissolved substances that share a common ion, then the solubility of a salt becomes more complex to determine. For example, it's relatively easy to perform calculations relating to the solubility of a saturated solution of silver chloride in water, since all the silver ions and all the chloride ions come from one compound. If, however, we wish to study a solution that contains both silver chloride and silver nitrate, then a more complicated situation arises. In this case, the silver ions have two sources, the silver chloride and the silver nitrate. The only way you can solve this is ice. Only way you can do it. So here we go. Given the KSP for silver chloride is 1.58 times... Please do that every time I say it, all right? Given the KSP for silver chloride is 1.58 times 10 to the negative 10th, calculate the molar solubility of silver chloride in the following. So letter A is the easy one, in pure water. So letter A is what we've been doing. So here we go. The reaction is
It's a Q.
AG. That's an A.
Fix your letters.
AG. You fix your letters.
That's a 9, guys.
AgCl solid in equilibrium with Ag plus Cl minus. I gave you a nice one here. Initial concentration
Oh my gosh.
for AgCl is
We already did this.
We did this. I'm just showing you the difference, okay? 0, 0, plus x, x, x. So KSP is going to equal x squared, right? Yes? Right? So that means that 1.58 times 10 to the negative 10th is equal to x squared. And x ends up being what?
1.26 times 10 to the negative 5th.
I got 3.6.
I get 1.26 times 10 to the negative 5th molar.
Oh, it's fine.
So there is my molar solubility of silver in the first one. For B, it's different. My reaction is still AgCl, solid, is in equilibrium with Ag plus Cl minus. Here's my ICE, nothing, nothing, nothing. Now, what is my initial concentration of silver in a solution that has a silver ion concentration of 5.5 to 10 to the negative third?
This is hard to find.
It's going to be 5.5 times 10 to the negative third. So you can start out with a concentration on the other side if there's a common ion. It's possible. Chlorine is still 0, right? So now it's going to be plus x, 5.5 times 10 to the negative third, plus x, and x. So we have to sub that into our KSP, right? So I know that my concentration of Ag plus, I don't know, I'm doing this backwards, times the concentration of Cl minus is equal to Ksp. And I know that I have 5.5 times 10 to the negative third plus x times concentration of x is equal to 1.58. It's still the same one, right? 1.58 times 10 to the negative 10th, which would make this 5.5 times 10 to the negative third x plus x squared, right? Agreed? Is equal to 1.58 times 10 to the negative 10th. How are you going to solve this?
Graph.
You got to graph it, right?
Easier than quadratic.
You're going to have to graph that. Let's get your answer. What do you get for x?
2.87 times 10 to the negative.
Yeah. 2.87 times 10 to the negative 8 molar.
That's right.
He did that.
Try C
Graph and find the
on your own.
Uh-oh.
Try C on your own.
C?
C.
C.
So C, I'm adding a common ion. Do I care about the K in KCl? No. I do care about the Cl though. I do care about the Cl. You're gonna get so tired of writing ice. Rice, sorry. I'm gonna do my work, you guys do your work. Fair? You should know how to do this part, Brendan. You saw this part. It's just the shifting stuff that you didn't see. We started watching The Sound of Music last night.
So
It's really good. I remember I thought it was stupid when I was a kid, but I actually like it now.
I've only seen like the first half.
Well, it's a 3-hour movie, so
Well, it's always on TV.
it's a
And I go to
commitment.
bed before.
It's on Disney Plus.
I just watched that and Life is Beautiful.
Nice. Yes. There you go. Did you solve it, Vince?
I did not solve it yet. I'm just getting to that last part. This actually makes so much more sense than the last unit did to me.
Good. Because this is what all the rest of chemistry depends on. So.
Okay,
Oh,
yeah.
don't tell me that.
Dude, I heard that in the
Why would you say
video.
it doesn't
That was like
work?
the intro to the video. The
Yes.
first video was like, yeah, so if you don't know this, you at least have half a credit.
And
I
then,
was like,
yeah. Is that what I said to drop the class?
Yeah.
Yeah,
You're
literally,
you
I'm
don't
just-
get,
I'm
guys, if
sitting
you guys
there.
don't get this, just
Oh my
drop the class.
God.
Yeah.
dude, I'm sitting there in my bed and I'm like, what?
Joke's on you. You can't drop anymore.
You can't.
Yeah, it's been past the 2 weeks.
Yeah. I think it's only 5 days that in second semester.
You can still drop it.
You can withdraw.
Well, it'd be withdraw fail.
What is sad?
That's not a drop though.
That's
You get an F, right?
Yeah. They wanted me to drop this class to graduate, and I was like, no, I don't want to do that.
No.
Sorry.
Are you serious?
Yeah, because they wanted to run the schedule. Because my schedule first semester was completely backwards of how it is now. 'cause
Are you
I
still
only-
graduating?
Well, yeah, but I had like 5 classes, and I had 2 junior privileges. So they
Your
moved.
counselor told you to drop AP Chem?
Yeah. Like I had AP Lang 3rd period, so they just moved it to 1st period, got rid of my privilege, and put in another English. So now I have 3 Englishes, but they wanted just to drop me down.
That's a lot of reading and writing.
What? How did I have 2 junior privileges? I had one first and 7th period.
Yeah, how
Like,
they let you
the seven, because I was in band for only a quarter.
I'm not
So I had
sure.
quarter privilege.
Is your stat plot
I
on?
have quarter privilege. You make it, if I don't play an instrument.
Is
I'm
someone
not
good at,
playing
can
band.
somebody good at graphing help
So I
Allison
get
and
band
Aubrey?
What's
the first
happening?
quarter, second quarter, I don't have so much.
Wait,
So
what's
I have
the-
study
what's
hall, so
not
instead of study hall.
I got to where this. You didn't have the circle.
Oh,
Graph it?
I don't know.
Yeah.
That is very confusing, actually.
You have
I would say you graph it.
Can you just sub it into y equals and then,
Yeah.
do you have to hit zoom 9 after you graph it?
It's like a very
Stat
odd
plot.
thing.
The 3D.
It seems like something Jake might somehow know.
Jacob will fix it.
Yeah.
Oh, look.
There he is.
Fine.
Can you fix their calculators?
Calculators, what's wrong with
What?
Hold on, he's signing in.
Kobe?
He's following the right process.
Go to all the stat plots.
Okay, what's that?
Oh, instead of Adobe, it was Kobe. Sorry, oh.
It's like in
I'm talking about like the really bad ones.
Still loading. Go to
I
liquid.
think I remember what you're talking about.
Wait, do they have like an inventory?
When
thing?
so-
Just quad form,
just like
program.
5 to 5.
You just think you have Kobe headphones.
That's sweet.
That would be really
What? I heard it was like.
He had the quadratic formula just programmed in.
Yeah.
It's the exact same font.
Oh. It's taking a little while.
Dude, I need me
It's a
some
straight
Kobe's.
line.
It's like a million of them.
It's loading.
I wonder why I play
I think it was cute.
Did you graph it?
Yeah, I don't really.
What'd you get?
I need that.
Push the window button.
I know.
That should get.
Why did Zoom 9 not work?
Did Zoom 9 not work?
How do I get a?
Well, it's a small number.
You are. Can I
Okay.
buy this on
So,
Fix it.
it's not 0, it's just close to 0.
Fix mine.
Zoom, hey, what's your standard?
Press button. He just was like, when I do it, like my big, this way just like, no, that's where.
Oh yeah, it is. Zoom standard works.
Yeah, I don't know, I don't know.
I had 6.32 times 10 to the negative 9th molar.
Oh, that's what I got.
6.32 times 10 to the negative 9th molar.
Why?
Is that Desmos on your phone? Are you using, Marin?
I don't
Yes.
even know.
Desmos graphing calculator.
That much is good.
Dude, best calculator.
All right,
Generally.
we gotta keep moving. You guys have to ask your math teacher about that.
What was the number?
Oh, sorry. 6.32 times 10 to the negative 9th.
No.
You know what it should be.
Are we doing number 2? What is?
Oh, number 2? Oh, purely in terms of Q and K, let's just talk about 2. No calculations required. Why is barium sulfate less soluble in a solution of sodium sulfate than water?
Because sulfate. Yeah.
What about it?
Sulfate. Sulfate has neither a K nor a Q. This is hard. It just has a sulfate.
Why would it be less soluble?
Yeah.
Because there's already sulfate in the solution.
I don't know how you bring K and Q into
Nice
this.
one.
It's oversaturated.
User has to register.
How'd you grab
It's just the charges, right? I have twice the amount of ions of barium than I do sodium. Agreed?
Yeah.
So, that means I'm going to have more what? If I have more ions on the right side, I have more products. Agreed?
Yeah.
That's true.
If I have more products, which way is it going to want to shift?
Right.
Ah.
Oh, wait,
Ah.
Back to the
Yeah,
reactants.
yeah,
Did you
you're
say
right.
right?
I said right. I
Right
To the
realized.
left.
Yeah.
If I have more ions, it's going to want to shift the other way. So you're just comparing the number of ions there in solution. Flip
So I
it.
should write shift right.
What does pH have to do with equilibrium?
Ion.
There's more. Ions, you're right. That's the first word.
Go!
When one of the ions in a salt can act as an acid or a base, pH can influence solubility. This is actually kind of easy. For example, in the case of iron 3 hydroxide, the following equilibrium can be established. FeOH, that should be a small 3, is an equilibrium with Fe3 plus 3OH minus. Addition of acid, H plus, in this equilibrium will cause the what to be removed?
OH minus.
That's going to cause the OH minus to be removed, right? Because the H plus is going to want to connect to the OH and make what? HOHs. Water. If I'm removing OH, right?
Shift right.
It's going to shift to the forward. I said forward because I said shifted. You can say forward or right. So if I'm adding H plus and it wants to react with this, I'm removing products, therefore shifts back to the products. And the solubility of iron 3 hydroxide will do what? Increase. It will increase because now it's going to be shifted more towards the products. Yes? If I added OH in this equilibrium mixture, it's going to shift to the left because now I'm adding in actual more products. Yes? So it's going to shift back to the other side. More complicated scenarios arise when the anion of the salt is a strong base. In other words, it's the salt of a weak acid. We'll talk about that more in a little. Not yet.
Sus.
All right? A strong base is the conjugate. Wait, did I say conjugate? Sorry. We haven't talked about that yet. For example, silver ethanoate sets up the following equilibrium in solution. So here's how silver ethanoate dissolves. On this one, if I increase the H plus concentration of the solution, in other words, I'm making it more what? Acidic. Then the hydrogen atoms are going to react with what?
I guess the ethanoate.
They're going to react with this. Yeah, because I told you, right? Making this. Because once I rip this off here, I'm actually adding the H to it. Then I have this equation here. So the CH3COO minus ions are removed from the equilibrium mixture. If I'm removing it from the equilibrium mixture, it's going to shift to the right. Yeah. Going to shift to the right according to Chateliers principle, which means now silver ethanoate is more soluble at lower pHs. The final example. Involves lead 2 carbonate and sets up the following equilibrium. PbCO3 solid is an equilibrium of Pb2 plus and CO3 2 minus. In acid, the carbonate ions react. If I add in H plus, what's the question?
What is the N?
That odd symbol.
I don't know why that's there. I think that's supposed to be equilibrium. I think Word did something weird there. All right?
Wow.
So if I add H plus to it, the H plus is connecting to my CO3 2 minus, right?
Yeah.
And that's going to make water and CO2 minus. So the lower the pH, the more CO3 2 minus are removed from the equilibrium system of lead 2 carbonate in the first equation. That causes the equilibrium to be shifted right, and therefore increases the solubility of lead 2 carbonate. Let's do number 1 first. Then we'll stop there for the day.
What is the second word?
Where? Removed, obviously.
Fix your letters.
I know. Fix my letters. We've been talking about that from.
I actually see now, Mr. Howard.
It looks like
It says removed.
I said reuse.
Yeah.
All right. We're going to do number 1, and we'll call it a day. Then on. Wait a second. Are we doing 11 Wednesday or Thursday next week?
Wednesday, you said.
At least that's what you
Well, it
said.
might be Thursday.
It's either Wednesday or Thursday.
Might be Saturday.
I'll put it on Google Classroom. I'll let you know. In which of the following pHs would you expect iron 3 hydroxide to be the most soluble?
4.5.
Why?
You know, the hydrogen ion.
Well, lower pH is more what?
Acidic.
Acidic. If it's more acidic, I'm adding in more
H plus.
H plus.
Which are
If I'm
taken
adding in more H plus, I'm getting rid of more
OH
OH minus, therefore removing
product.
products, shifting it to the.
Right.
Wow. Well done.
Let's
Well
go.
done.
We did not do that.
What is red?
Yes? Allison.
This part here, when it says the lower the pH, the more the CO3 2 minus are removed.
Right.
If reactants are being removed, why would it shift it to the right?
So,
Reactants react.
if I'm removing this, causing the equilibrium to shift, I said to the right. If I remove reactants, oh, because I'm looking at the second equation.
Caleb,
I'm looking at the second equation, not the first.
I've never seen that show. Just on
I'm
Apple.
shifting, causing equilibrium to shift. No, in the first equation, I'm talking about the first equation. I'm removing product. Removing product. Yes,
Why does shifting it right make it more soluble?
because more ions are being produced.
Describe his
More ions are being produced. More is dissolving. Hi.
So I just sent an email about fourth period tomorrow.